Hello students, in today's video lecture, we are going to learn how to solve the system of equation by using matrices. So in the previous video lectures, you learned what is the basic operations and how to find the determinant and inverse of a matrix. Now we are going to use these concepts to solve the system of equations. So there are two different methods to solve the system of equation. The first one is the Cramer rule, the second one is the inverse method. So I am going to teach you how to solve a system of linear equation by using Cramer's rule. This Cramer's rule is named in honor of a Swiss mathematician G. Cramer. The method is very simple. So this is known as a system of linear equation. So it always have some coefficient before the variables. So this x, y, z are known as variables, unknown variables. This is what we are in need of find. Okay. This a1 is the coefficient of x, b1 is the coefficient of y, and c1 is the coefficient of z. And d1, d2, d3 are some constants. Okay. So now I am going to teach you how to find this a. This a is nothing but the coefficient matrix. So coefficient matrix means the coefficients of x. The first column will be completely the coefficient of x. The second column is the coefficient of y. The third column is the coefficient of z. So look at the equation. The coefficient of x is a1, a2, a3. This is your first column value. The second one is the coefficient of y is b1, b2, b3, and that is the second column. The third column is c1, c2, c3, and that is the third column, right? Okay, now you know how to find the matrices capital A. Then next one is AX. AX is nothing but, suppose if it is AX. So what is the column of X? This is the first column. First column values are all the coefficients of X, right? So instead of the coefficient of X, you have to write the constant value. These are the constant value, right? D1, D2, D3. So if it is AX, then you have to write this D1, D2, D3 in the first column. That means the X coefficient column. If it is AY, then you have to write this in the second column. That is coefficient of Y column. And that is if it is AZ, then you have to write in the third column. That is coefficient of Z column. Hope you understand it well. So once they have given a system of equation, first you have to segregate that A, AX, AY, AZ according to the definition. So you know how to find this A? It is simply the gathering of the coefficients of X, Y, Z in a given format. And AX is nothing but the replacement of the constant instead of the coefficients of X. And AY is nothing but the replacement of the constant instead of the constant instead of the coefficients of Y. And AZ is nothing but the replacement of the constant instead of the coefficients of Z. Okay. So then once you frame this matrix as AX, AY, AZ, then it is very simple to find the X, Y, Z. So this X can be found by the determinant of AX divided by the determinant of A. So in the previous video lectures, I taught you how to find the determinant. So by using the methodology, you could find the determinant of a matrix, and you have to find the determinant of AX and A. Once you divide both the values, you will get the value of X. Similarly, you can find the value of Y and Z. Okay. So in today's video lecture, I am going to teach you one 2 by 2 matrix as an example and another 3 by 3 matrix as an example, and how to solve this system of equation by using this Cramer rule. Right. So this is the first system. Solve x minus 2y is equal to 16. 3x plus y is equal to minus 1. Solution. Right. So what is our methodology? First you have to write the A. So A. What is the A? A is the first column is the coefficient of x and the second column is the coefficient of y. So look at the equation. What is the coefficient of x? It is 1. What is the coefficient of y? It is minus 2. And look at here, what is the coefficient of x? In the second equation, it is 3 and the coefficient of y is 1, right? And we know the d1, d2 value, that is 16 and minus 1. So next I am going to write this ax. Ax is nothing but the coefficient of x must be replaced by the constant which is given in the equation. So that is 16 and minus 1. The other variable y as it is in A. So it is minus 2 and 1. Next is AY. AY is nothing but 1, 2, 1, 3, which is given as the coefficient of x, same as it is. But instead of coefficient of y, you have to write the constant which is given in the equation. So that is 16 and minus 1. Next is AY. AY is nothing but 1, 2, 1, 3, which is given as the coefficient of x, same as it is. But instead of coefficient of y, you have to write the constant which is given in the equation. So that is 16 and minus 1. constant values, that is 6 and minus 1. Right? So now you find ax, ay. Why I have written only ax, ay and why didn't write this a is that because only two variables we have to find, that is x and y, because it is a linear system of two equations. So there are two variables x and y. So we need to find only two variables. So I have written only two matrices. So how will you find the value of x? The value of x will be determinant of ax divided by determinant of a, and the value of y will be determinant of ay divided by determinant of a. Right? So now before proceeding with the solution set, I am going to find the determinant of these matrices. So what is determinant of a? So determinant of a is nothing but 1 minus 2 3 1. So and I taught you how to find the determinant. So it is 1 plus 6, that is equal to 7. And determinant of ax, this is 16 minus 2 minus 1 1. So it is 16 minus 2, that is 40. And next is ay. Ay is 1 3 and 16 minus 1. It is minus 1 minus 48. So it is minus 49. So now I am going to use the formula. I am in need of finding x. So x is equal to determinant of ax divided by determinant of a, and that is 14 divided by 7, that is equal to 2. Right? And the y value is equal to determinant of ay divided by determinant of a, and that is minus 49 divided by 7, that is equal to minus 7. So we found that the x value is 2 and y value is minus 7. Right? So this is the solution for the given system of equation. If you want to find whether you found the value correct or not, and you can do with the verification. Okay. So this is the verification part. You can take any one of the equations. So I am going to take the second equation. Second equation gives that 3x plus y equal to minus 1. So I am going to substitute these values in the second equation and I will check whether I am getting minus 1. So 3x plus y. So 3 into my x is 2 and plus y. So plus y is plus minus 7. 3 2s are 6 and minus 7. This is equal to minus 1. It is verified. Right? So in a similar way, now I am going to teach you the system of equation with 3 variables. Okay. Look at the equation. So there are 3 different equations with 3 variables x, y, z. I am going to teach you how to solve this system of equation by using Cramer's rule, and I already taught you. Okay. Solution. Now we are going to write the matrix A. This is this procedure. So I am going to write A. My A is 3 minus 1 2 1 1 1 2 1 minus 1. Please check the coefficient. The coefficient of x is 3 1 and 2, and coefficient of y is minus 1 plus 1, and the coefficient of z is 2 1 minus 1. Right? Now I am going to write ax, ay, az, because here we have 3 variables. Right? Ax is equal to, now I am going to replace the coefficient of x with the constants. So the constant values are a and 2 and minus 1. Remaining matrices value will be same, 1 1 1 and 2 1 minus 1, and ay is equal to, so I'll keep the coefficient of x as it is, that is 3 1 2. I'm going to replace the coefficient of y with the constant values, that is 8 2 minus 1, and z coefficient value as it is. Similarly, I can write a is that. Okay. So please write by yourself so that you can verify whether we are doing it correctly. So it will be 3 1 2 and minus 1 1 1 and 8 2 minus 1. So these are the three different matrices which we need to find the values of x, y, z. So before to finding the value of x, y, z, I am going to find the determinant of these matrices. Okay. So first is determinant of A. That is determinant of 3 minus 1 2 1 1 1 2 1 minus 1. You can take any row or column to find the determinant of this matrix. So I am going to take the first one, 3 into minus 1 minus 1 plus 1 into minus 1 minus 2 plus 2 into 1 minus 2. So this would be 3 into minus 2 plus 1 into minus 3 plus 2 into minus 1. So this is equal to minus 6 minus 3 minus 2. So which is equal to minus 11. So next I am going to find Ax, and that is equal to determinant of 8 minus 1 2 2 1 1 minus 1 1 minus 1 is equal to 8 into minus 1 minus 1 plus 1 into minus 2 plus 1 plus 2 into 2 plus 1, which is equal to 8 into minus 2 plus 1 into minus 1 plus 2 into 3. So it will be minus 16 minus 1 plus 6. So minus 16 plus 6 is minus 10. Minus 10 minus 1 will be minus 11. Then Ay is equal to determinant of 3 1 2 8 2 minus 1 2 1 minus 1. Okay, and this will be 3 into minus 2 plus 1 plus, sorry, it is minus. Minus 8 into minus 1 minus 2, then plus 2 into minus 1 minus 4. So it is equal to 3 into minus 1 minus 8 into minus 3 plus 2 into minus 5, which is equal to minus 3 plus 24 minus 10. So minus 3 minus 10 will be minus 13. Minus 13 plus 24 will be plus 11. Okay. Similarly, I am going to find A is that. So determinant of A is equal to 3 minus 1 8 1 1 2 2 1 minus 1, which is equal to 3 into minus 1 minus 2 plus 1 into minus 1 minus 4 plus 8 into 1 minus 2. So this will be 3 into minus 3 plus 1 into minus 5 plus 8 into minus 1, which is equal to minus 9 minus 5 minus 8. So minus 9 minus 8 minus 5 will be minus 22. So we are going to find x. X is nothing but determinant of Ax divided by determinant of A, and we found determinant of Ax is minus 11. So minus 11 divided by determinant of A is minus 11, and that is equal to 1. And to find y, determinant of Ay divided by determinant of A, which is equal to determinant of Ay is plus 11 divided by minus 11, which is equal to minus 1, and determinant of A is that divided by determinant of A, which is equal to minus 22 divided by minus 11, which is equal to 2. So we found x, y, z. X is 1, y is minus 1, z is 2. Okay, I am going to substitute these values in equation and verify whether we found it correctly or not. So I'm going to take the second equation, verification. So my second equation says that x plus y plus z must be equal to 2. So x is 1, y is minus 1 and z is 2. Okay. So it was equal to 2. So it satisfies the second equation. So the answer which we found is correct. Okay. That's it. Hope you understand how to find the system of how to find the solution for the system of equation by using Cramer's rule. It is very simple. First you have to observe the system of equation. Then you have to combine the coefficients of x, y, z together and form a matrix capital A. And you have to find capital A x. That is, you have to replace the coefficients of x in with the constant values. Okay. And similarly, you have to do with ay and az. Once you formulate ax, ay, az, etc., then you have to find the determinant of these matrices. Then by substituting in the formula of x is equal to determinant of a matrix ax divided by determinant of a, you could find the value of x. In proceeding this way, you could solve the system of equation. Right? Hope you understand clearly about the Cramer rule and how to solve the system of equation. Okay. Next, I am going to teach you how to solve the same system of equation by using inverse method. We already learned inverse method. Right? So I am going to teach you how to solve the system of equation by using inverse method. So inverse method, it is very simple. If the system of linear equation, it is the same structure which is I have explained previously, and the A is very similar because that is a coefficient matrix. The coefficient of x, here it is coefficient of x, okay, and it is coefficient of y and coefficient of z. So you have to write the coefficient of x as the first column element, and coefficient of y as the second column element, and coefficient of z as the third column element. And here we are going to give some names for the constants, that is capital B. Capital B is equal to d1, d2, d3. And the variables which we are in need of finding, that is x, y, z. So x, y, z, that is we have to find. So there we have some formula, that is capital X is equal to A inverse B, actually which we derived from this system. So this system, A into capital X is equal to B. When you observe this, this A is a 3 by 3 matrix, okay, and this capital X is the system equation of 3 by 1 matrix. If A into X, if you find, that will be again a 3 by 1 matrix, and this is the, that matrix which you are getting this B, okay. So this is the system of equation. If you do matrix multiplication, you will get this linear combination, linear equations, okay. So from this you can find, if you multiply both sides with A inverse, right, you will get A inverse by matrix multiplication. It will be a unit matrix. Unit matrix, instead of unit matrix, we can consider that as 1. So it is x is equal to A inverse B. This is how we derived that as x is equal to A inverse B. So now I am going to teach you the same example which I taught you by Cramer's rule, right? We are going to solve the same problems by inverse method. So the same equation, solve the system of equation by inverse method, okay? So solution, we are need up to find A. A is nothing but the coefficient of x and y. So coefficient of x is 1 and coefficient of y is 2. And the coefficient of x is 3 and the coefficient of y is 1. Then your capital B is the constant values, that is 16 and minus 1. And your capital X is variables which you need to find, that is x and y. The formula says that capital X is equal to A inverse B. Okay. So you need to find of A inverse, you must find A, whether the determinant of A is possible to find or not. If it is possible, then only you could proceed with A, right? So first find the determinant of A. Determinant of A is 1, minus 2, 3 and 1. So the determinant will be 1 and 3 2s are 6, it is 6. That is equal to 7. This is what we found in the previous one, right? And A inverse nothing but adjoint of A. A inverse we can find by 1 by determinant of A into adjoint of A, right? So 1 by determinant of A is 1 by 7 And adjoint of A, you know how to find the adjoint of A, right? You have to interchange the main diagonal and you have to sign change for the another diagonal. So it will be 2 and minus 3. Right? This is what A inverse. So now our methodology says that X is equal to A inverse into B. So which is equal to 1 by 7 into 1, 2, minus 3, 1 into your B is 16 and minus 1. This is a matrix of 2 by 2 and this will be 2 by 1. So we'll get 2 by 1 matrix. So we'll keep the 1 by 7 as it is and this will be 16 minus 2 and minus 48 minus 1, right? So 1 by 7, 16 minus 2 is 14 and minus 48 minus 1 will be minus 49. If you divide this equation, this would be 2 minus 7, right? This is your capital X. Your capital X is nothing but X and Y. And from this you could find this A is 2 and X is 2 and Y is minus 7, right? This is what we found in Cramer's rule also, right? This is very easy method to find the solution of a system of equation. Next we are going to see how to solve a system of equation of a 3 by 3 matrices. Okay. Solve 3x minus y plus 2z is equal to 8. X plus y plus z is equal to, actually it is z is equal to 2 and 2x plus 3 y minus z is equal to minus 1. Okay. Now I am going to solve this system of equation by using inverse method. Solution. Now we are going to write what is A, B, C. So A is nothing but the coefficient matrix, that is 3 minus 1 2 1 1 1 2 1 minus 1 and your B is nothing but the constant values 8 2 minus 1 and the variables capital X is equal to X, Y, Z. So in order to find your capital X, our formula is X is equal to A inverse B. To find A inverse, you have to use the formula A inverse is equal to 1 by determinant of A into adjoint of A. Okay. To find the inverse, you must check whether the determinant is exist or not. If the determinant exists, then only you could proceed. So I am going to find the determinant, and in the previous Cramer's rule itself, we found that determinant of A is minus 11. So it is not equal to 0. So I could proceed with the adjoint of A. So adjoint of A. Adjoint of A is nothing but I have to find the coefficient cofactor matrix of each element. Okay. Suppose for this is my first element. Then the cofactor matrix will be 1 1 1 minus 1, right? Minus determinant of 1 1 2 minus 1. Then 1 1 2 1. And I am going to find the transpose of this. Okay, then next will be minus 1 2 1 minus 1, then 3 2 2 minus 1, then 3 minus 1 2 1. Then I have to put negative sign here. Then it will be minus 1 2 1 1, then 3 2 1 1, then 3 minus 1 1 1, right? So this will be if you find it will be minus 1 minus of minus 1 minus 2 plus 1 minus 2, right? You have to find the transpose of this. And similarly minus of 1 minus 2 and minus 3 minus 4 minus of 3 plus 2. Then minus 1 minus 2, 3 minus 2, 3 plus 1. So this would be minus 2. It is actually minus 3. Minus of minus 3 is plus 3. And 1 minus 2 is minus 1. 1 minus 2 is minus 1. There is already a negative. So it will be plus 1. It is minus 7. And it is minus 5. Okay. Minus 3, 1 and plus 4. I have to find the transpose of this. So this will be minus 2, 1 minus 3, 3 minus 7, 1, minus 1 minus 5, 4. This is the adjoint of the matrix. Okay, and there is also a negative, so it will be minus. Right. So next I am going to find the A inverse. Right. So A inverse is equal to 1 by determinant of A into adjoint of A. So that is 1 by minus 11 into adjoint of A, that is 2, 1 minus 3, 3 minus 7 minus 1, minus 1 minus 5, 4. Right? And to find value of x, that is x, y, z, I have to substitute in the formula A inverse B. So it is 1 by minus 11 into minus 2, 3 minus 1, 1 minus 7 minus 5, minus 3 minus 1, 4, and the value of B is 8, 2 minus 1. So this is, you just keep the constant as it is and do the multiplication. So it is minus 16 plus 2 plus 3 and 24 minus 14 plus 1 and minus 8 minus 10 minus 4. And this is equal to 1 by minus 11 of 16 minus 2, 16 plus 5, minus 16 plus 5 will be minus 11. 24 minus 14 is 10, so plus 10 plus 1 is 11, and these are all minus, minus 8 minus 4 is minus 12, minus 12 minus 10 is minus 22, right? So if you divide these values, this would be 1, minus 1 and 2, and this x is nothing but the values of x, y, z, and from this we could find this x is equal to 1, y is equal to minus 1 and z is equal to 2. These are the same values which we found in the previous method, Cramer's rule, right? So once you know how to find the determinant and the inverse, then you can solve the system of equation by any one of the method and find the solution of the system of equation. Hope you understand it clearly. In the next video lecture, I will come up with a new concept. Thank you.